Hello students, today we're going to do section 2 of chapter 10. Half-life. Half-life is the time required for half of a radioisotope to decay. So if you take a look at this picture, this at the beginning, this would be the whole isotope. After one half-life, it only then has 50% of it left. So half of it decayed, so half of it turned into another element. Then after another half-life, another 50% decayed, so you'd only have 25% of the original isotope, and so forth. Here is a table. You don't need to copy this down, but it just shows you that there are different half-lives for every different type of isotope. So we've got radon-222, that has a half-life of 3.82 days, so every 3.82 days, half of it decays. Thorium-234 has 24.1 days. So every 24.1 days, half of it decays. After another 24.1 days, half of that, another half decays. And then radium-226 is 1,620 years. Carbon-14, which we'll talk about a little bit later on, has a half-life of 5,730 years. And I want you to just realize that just because it's thorium, it can have a different half-life. So thorium-230 has 75,200 years. So different isotopes can have different half-lives of the same element. So we've got thorium-234 here and thorium-230 here, and both of those have different times. And you can even have half-lives in the seconds as well. Okay, here are some equations that you'll need to know. Well, this equation up here and this equation, both of these equations will be given to you on the test, but you need to know how to use them. In this equation, the first one, n equals n, that 0 as a subscript is often said n naught, times 0.5 to the little n. N is the remaining amount, and naught is the initial amount, and then the little n is the number of half-lives. To figure out the number of half-lives, you take the time elapsed over the half-life time. So we are going to do an example problem. So fluorine-21 has a half-life of 5 seconds. How much of a 1,230 gram sample remains after 70 seconds? First, you'll want to write down both equations, and I always start with the little n one. So n equals time elapsed over half-life time, and you can abbreviate half-life time as t1/2. Then you can solve for that one. So our half-life time was 5 seconds, and the time elapsed was 70 seconds. So you're going to take 70 seconds over 5 seconds. That equals 14. The seconds cancel out, so you're just with 14. Then you want to have your other equation, so capital N equals n naught times the 0.5 to the 14 to the little n. Then what you're going to do is you're going to fill in what you know. So we're looking for n. The n naught is the 1,230 grams. And then you're going to take 0.5 to the 14th. Now, you only do 0.5 to the 14th, and then you take that times 1,230 grams. So your n is going to equal, and that will equal 0.075, and we'll carry the grams down. So it'll be 0.075 grams. You should pause and try to do this one on your own. So you first need to solve for the little n again, which is time elapsed over half-life time, which again is t1/2. And time elapsed was 22,920 years, so 22,920 years over 5,730 years. That equals 4. Then you want to do the next equation, so n equals n naught times 0.5 to the little n. we had 80 grams to begin with, so we have 80 grams times your 0.5 to the fourth. So remember, you're doing the 0.5 to the fourth first. If you take 0.5 to the fourth, you get 0.0625, and then you times that by 80. And that will give you 5 grams. A little bit more, radioactive dating. You might have heard that sometimes when they find old things, they can say how old an object is when they do an archaeological dig. And there are different isotopes that you can use, but then one of the most common is carbon-14. So you might have heard of carbon-14 dating. And when you're living, you have a certain ratio of carbon-14 to carbon-13 in your body. But when you die, you stop taking in the carbon-14, and carbon-14 keeps decaying. So based off of the percentage of how much carbon-14 you have left, you can determine the age in it, because the age of the object is determined by comparing with carbon-14 levels in the object with the carbon-14 levels in the atmosphere. And then they can see how much is left and how much is decayed. And if you remember, the half-life of carbon-14 is 5,730 years. They kind of work backwards to figure out how old it is. And that is it for today's notes.